All right. Hi. I hope you're fine. So we continue our discussion. Just wanted to kind of apologize again. I was unavailable most of last week. I actually thought I was going to have class. Can you hear me, by the way?
Yes, can hear you.
Yeah. I thought I was going to be able to have class where I had traveled to, but I think it was going to be in bad taste, as they say. It was a funeral, right? So to cut the thing short, we will have makeup sessions. We'll come up with an arrangement immediately after we write the scheduled assessment, which is on the 11th. It's on Friday. That's a test. So I am aware that I think we've probably missed out on about 2 weeks. I think, if my memory serves me right, we will have makeup sessions for those missed out days. And so with that being said, just to remind us that there's a couple of things that are currently pending. And incidentally, all of these are actually due on the 11th or something, if we can use the word due here, whatever that means. But assignment 25, 26, and 27 are due on the 11th of September, right? This is just the partial SRS document. We did mention that it doesn't have to be complete because there's certain design artifacts that you cannot put in there because, lo and behold, we are meant to start discussing those artifacts beginning lecture series number 7. In fact, we're going to continue discussing these artifacts all the way up to, I think, lecture series 8 and 9 as well, right? So the idea, as earlier mentioned a while back, the idea is for us to be able to come up with a version of the SRS document that will only incorporate things that we are able to include into the document. And we know how this works now, right? We know that what we have to do is version control our SRS document, be able to do this here, right? So somewhere in your SRS document is, I think it's on page number 2 or something, is a page that tracks the revision history of your document, right? So seeing as this is going to be version 1.0, which is the initial version of the SRS document, subsequent versions that are going to incorporate design artifacts as and when we discuss them are going to be incorporated into the SRS document, and then you version control it, right? So you include the version and you provide a reason as to why you're version controlling the SRS document. Interestingly enough, we also introduced, in terms of version, we also made mention of the fact that one of the ways in which you can version control your SRS document is by using CVS software, right? We discussed version control software immediately after this, I believe. Though it's a bit unconventional for you to version this sort of documents using tools like Git, but it is possible, right? So every time you create a new version of your SRS document, you create a commit message, right? So something that's akin to, I'm just going to use I guess just this we discussed, but I'm just going to use paper. I'm just going to use this as an example, right? So you version control, you create save points associated with whatever changes you've made, right? And each save point will typically be associated with a date. So you slot this document, the document into a repository that you version control, right? So you have an initial commit message, and then every time you make a significant change to the document, you create a new version. Or you version control it, you create a new commit message, right? With a corresponding date and time when that particular commit message was done. And the reason you're doing this is that at a later stage, you get to reference whatever version you want by just gaining access to your repository, right? And we discussed this, very easy, trivial to use. It turns out that the real power of CVS software or version control software lies in trying to maintain versions associated with your source code. But still, you can still use it in this particular case. It's because the case tools that you'd otherwise end up using slightly on the higher side, right? They're not exactly cheap. you need to pay money for the tools, right? But also, if you found yourself using a sophisticated project management tool, if you remember, like OpenGoo, for instance, right? Or Open Prod, you can actually version control these documents. I don't know if you guys remember this, right? We said, Open Project. Wow. Open Project. Oh, wait a minute. Maybe I have a slide that speaks to it. Is it number 3? Lecture series number 3 or something? I don't know. I think so. I don't know. Maybe. When we looked at, I think it's 3. I'm just trying to remind us of some of the case tools that we discussed. Now I know our interest was mostly on this is an interaction. Our interest was, for the most part, on specific features associated with these tools. And I remember one of the things we were obsessing about were so-called Gantt charts, right? Timelines. But it turns out that, oh wow, I don't know, what's the track here? Can't remember. Anyway. Okay, I've forgotten which lecture series we discussed. Oh, it's here maybe. Is it? No 3D. Okay. I've forgotten which lecture series we're looking at project management tools, potential project management tools to use. Was probably lecture series maybe number 2 or something. Right. So what I'm trying to say here is that there are certain sophisticated tools, like I know I have worked with tools such as I don't know, don't remember this. I've worked with tools such as Open Project, OpenGoo, Fang Office now, which are incredibly useful, right? Useful because they have sophisticated features that will in part enable you to be able to version control documents. And I've done this in the past. One of the reasons I'm looking for Fang, by the way, is because number 5. The reason I'm looking for Fang Office was because I'm looking for here. Anyway, maybe it's in 1 or something. But as I'm looking for this, because it's important to talk about this, are there any specific questions that you might have, I guess, before we transition to the next lecture series? Oh, the memory. Gone. All right. Okay. It's not appeared, but there are sophisticated tools that you can use to version control documents, right? And they're incredibly useful because all you do is you continuously upload different variations of versions of the document up to a point in time when I guess you're done making changes to the document, right? So that way you can easily refer to whatever version you might be interested in, right? By just using one document. Again, a reminder that we have a test on the 11th, right? Prepare everything up to lecture series number 6. All right, so we start our discussion of so-called design or system design with a generic discussion of system modeling using UML. Now I was torn apart. I was trying to, when I was preparing these lecture slides here, I was tempted to incorporate specifics of how exactly you get to generate these artifacts into this particular lecture series. But I sat there and I thought maybe it would be wise for us to have separate or dedicated lecture sessions where we're going to discuss specific types of these models, right? So, for instance, under context models, so we're going to gloss over these different categories of models, right? And then in follow-up lecture series, perhaps lecture series number 8, we shall look at specifics on how exactly we get to actually come up with these models, right? So this lecture series is just going to gloss over this to just introduce these different categories. So we'll look at context models, interaction models, structure models, behavioral models, and then we'll have a short discussion about so-called model-driven engineering, right? So we're setting a stage for the specific discussion of a few select artifacts. There's a broad spectrum of things like interaction models, for instance. What you realize is that we will focus on, I guess, the most widely used, the things that you typically find in literature, but also things that we want to incorporate into our SRS document, right? Our discussion of context models is probably just going to be restricted to DFD level 0 and perhaps level 1 as well, right? And then on structural models, because of our mild introduction, hopefully, to so-called object-oriented programming using the Java programming language last year in 2010, we are going to focus on class diagrams, right? And then we'll look at some behavioral models like, I guess, activity charts and state machines, maybe, just so we have a feel of what's there. But it turns out that I just want to put it out there from the onset, there's a broad spectrum of, oh wow, I thought I had the UML thing here. There's a broad UML. There's a broad spectrum of, I don't think I'll be able to find this. Anyway. Wow, I thought I saved it somewhere. It turns out that there's a broad spectrum of, this here, I guess, I don't know. I thought I had oh, it's in downloads, I think. There's a whole bunch of, and I think I should share this with you. There's a whole bunch of, because our focus is going to be in UML here, obviously. There's a bunch of let's look at UML specification, right? There we go, object management group. So you'll notice that if you look at documents such as this, for instance, I hope this is on specification from OMG here. If I can find that document, you will find that there's a number of, I'm looking for the specification, this should be it. We're going to use 2.0 here, but it doesn't matter, there's a few differences here. So if you go to this link here, what you notice is that that document, just share it in the chat. What this document will have, it will have a broad spectrum of artifacts that are there, right? A lot of them. Let me just see here. Just let's wait for it to come here. All right. So it's a pretty massive document. I'm sure you've noticed that this is 700 and I don't know if you can see here, but this is 796 pages, right? And really these documents they're not really there to be read like books per se. It's a reference document, and so the idea is for you to be able to dump it somewhere. The idea is for you to be able to refer to it if you're uncertain about the way that you're supposed to design these documents, right? So if you go to the appendix section, for instance, in Annex A, right, you'll notice that they have, is it Annex A where they have examples of these artifacts? Anyway, I do encourage you to go through that document, right? So as we're discussing these specific types of models, you want to refer to the specification. The specification outlines details of how you're supposed to visually represent these documents. And again, so things like use cases. Again, one of the reasons why you want to obsess about these things is you might end up with a situation where you ship your SRS document to a person who has no idea what exactly it is you're building. But because you're following a standard, right? Because you're following a standard, and that person, hopefully you've hired a person who understands the standard, that person will be able to figure out exactly what it is you mean when you have this sort of artifact in your SRS document, just by looking at this, right? Anyway, I do encourage you to download that thing and go through it. All right. All right, so this is the outline of it's going to be the outline of lecture series number I don't know if it's number 7 or number 6 or something, number 7. And so we're just going to start off by just discussing system modeling. And as always, if you need to interrupt me, just feel free and interrupt me, right? The idea behind modeling, right? Modeling your system, the system that you want to implement here. Obviously, this stage follows through with requirements engineering, right? So you've created your, there's a thin line actually, right? Certain things will have to be incorporated in the requirements engineering process anyways. But the idea behind modeling is you're trying to come up with an abstract representation of the system that you want to build, right? And the reason why you have these different artifacts, so behavior, we're mentioning that we're going to talk about things like context models, interaction models, structure models, and behavioral models. What you're doing is you're trying to come up with this abstract representation from so many different angles, right? From the perspective of how users are going to eventually interact with the system, for instance, from the perspective of how the high-level entities that are linked to the system are going to have to interface with the system, right? It's tied to the context diagrams here, right? So different models representing different views or perspectives of the system, right? Now, some people refer to system modeling when they are describing the graphical notations, the different graphical notations that you end up using when you're designing your system, right? And specifically, once you, in our case, if you're using UML, right? So system modeling is normally synonymous to those graphical notations that we're going to look at, things like class diagrams, for instance. So it's one and the same thing. So whenever we're talking about UML modeling and system modeling, just remember that we're referring to the same thing here. Because we're saying that there are certain aspects of the modeling process or the design process that needs to be fed into the requirements engineering process, it makes sense here that our so-called business analysts, remember the role that is responsible for eliciting requirements and coming up with a formal representation of the requirements, right? Business analyst, or the analyst, as they were. The models will help the analyst understand the functionalities that are associated with the system, right? In certain instances, like high-level artifacts, such as the context diagrams, for instance, will be used to communicate certain information with your clients. And this makes sense. This makes sense because if you remember, we said that our SRS document, the one that's loosely based on the template associated with IEEE, we mentioned that there's a section within that document that is supposed to include a context diagram, right? DFD level 0. The reason it's going to be there is in part to convey a certain message to your customers. How? Well, we mentioned that the customer or your clients are going to be one of those people that are going to read the SRS document, make reference to the SRS document. In effect, we said, or we defined, we mentioned that the SRS document is a contract, a formal contract between you as a developer, right, and your clients or your customers. You must remember this, right? So we're saying the system modeling helps the analyst understand the functionality and also is used to communicate certain information to the clients. This because all of this is going to, some of it is going to end up into the so-called SRS document, right? Now, this probably doesn't apply to, it probably doesn't apply to these artifacts like these, right? The sticky figures. I'm sure if you went to your clients, right? You went to your clients and told them we're building a system, and this is one of the abstract models that we're using to build the system. They'll think you're playing. You understand what I mean, right? Think about this for a second. These are like things that toddlers draw, right? Sticky figures. But it turns out that there's a hidden meaning behind these things we're seeing here. Simple as they might seem, but very powerful message that they're conveying. Your clients will probably not really make sense out of this, right? And in fact, this sort of information is not really meant for them. And by them here, we are referring to a specific subcluster of your clients. the not so tech-savvy clients. If you're building a massive software for a large organization which has, I guess, a reasonably sized IT department, which obviously has a system development unit or something, there will be people that will be able to understand these things, right? But we're our reference to clients or customers in this case who might not make use of these things are the laymen out there, right? People that don't understand the technicalities associated with UML, for instance, in this case. Is this making sense? Are you still there? You never answer if it's making sense. Are you still there, by the way?
Yes, I do.
Okay, that's nice, I suppose. So and again, I mean, so a reminder here that these models, right? We're just reiterating things that we've already mentioned here. The models are typically used during the requirements, in certain instances, during the requirements engineering process. There are certain models that will help you refine the requirements that you're eliciting, right? Remember, one of the characteristics, or some of the key characteristics associated with requirements is they must be complete and comprehensive. And one way of ensuring that they're complete and comprehensive is by incorporating some of these models that will hopefully be a lot easier, or will make it a lot easier for you to explain what it is you're trying to do to your customers. Right? It's especially the case for existing systems. So for when you're building an existing system, right? Or when you're trying to refine an existing system, you typically use the models to clarify what the existing system does, right? If you're building a new system from scratch, what you're doing as part of the requirements engineering process using these models is to explain the requirements that you've elicited to your stakeholders. But of course, I mean, the engineers will typically use this as part of the design process, obviously. These days, I mean, if you take a model-driven engineering process or approach, what you discover is that you can actually derive a partial or a complete system actually from the system models themselves. And it's not uncommon actually, right? For small scale applications like this, the platforms the systems that you're building. I mean, this is probably, I don't know if this is proven here, but if I was to just come up with design artifacts like UML diagrams and class diagrams and perhaps interaction diagrams and give them to you, if you've studied software engineering, you should be able to build the complete software, right? Without really making use of other sophisticated aspects of the SRS document, essentially. Right. Yeah. So in terms of the different perspectives associated with the system here, a reminder that so your models will provide a lot more context about the system you're building and the environment which is going to be used to deploy the system, right? I think some of this will make a lot more sense once we look at context diagrams, because you will notice that what you do when you're actually coming up with a context diagram, it's level 0 DFD diagram, is you are just outlining the flow of data into and out of the system. Very powerful artifact, right? Because it highlights the different external entities that are going to be interacting with your system, right? So from an external perspective. And then in terms of the perspective to do with the interaction here, your models will showcase the different interactions between the system and the environments, right? And this environment would encompass things like users, for instance. So what typically happens when a person logs in, what sequence of events happens, right? What you will notice from diagrams such as, if I can find sequence diagram, I guess. Sequence diagram. I don't know if I'll be able to find a sequence diagram in this UML specification version 2 thing. I don't know if I'll be able to find it somewhere. I just want to showcase an example, I guess. Oh wow, I don't know. It's a large document. I wish I could. Maybe I could. I don't know. Oh, there we go. Maybe we can find. No. Anyway, it's not here. I guess I don't know. That's fine. That's fine. Wanted to. Oh, interaction diagram. Boom. Not here. Okay, so something similar to this, right? Where these directed arrows will outline the different sequence of events. So this would be a user interacting with the system, and then the level of interaction represented by these arrows will tell you. So initially, maybe the user will specify, I don't know which platform this is. So the user specifies a pin code, and then the system responds. What you're doing is you're modeling the interaction that takes place, right, between the system and the user in this case. This is a part of the environment, obviously. And incidentally, you soon discover that the interaction that takes place, because it's an environment, the interaction doesn't necessarily have to be restricted to an entity such as the user. It could, in fact, be an external system, right? So this could be like a web service, for instance, a web service interacting with the system that you're developing, right? And so what you're doing with an interaction diagram is you're outlining a sequence of events that happens as the system is interacting with external environment, essentially. And then in terms of the, again, still on different system perspectives that you're modeling here, there's a structural perspective where you try to model the organization of the system, right? In most instances, a different structure associated with the data that is going to be handled by the system. And in fact, the artifact that we're going to narrow down on, the so-called class diagram, will probably be the most intuitive, because it's linked to all concepts that were introduced to you in 2010. I don't know if you looked at object-oriented analysis and design during 2010.
So I have a question.
Yes.
Is it still?
Can I first of all ask if you've had a discussion about? Did you discuss object-oriented design in 2010?
I don't know.
Okay, maybe it was phrased differently. You should have. You must have. Did you look at abstract classes, interfaces?
We ended on UML diagrams.
Okay, all right. Okay, your question was?
Well, this is all pertaining to the SRS document, right?
No.
The perspectives.
No, this is to do with the design. So different models that you come up with. So there are some artifacts, some models that are going to feed into the SRS document. We're going to put them in the SRS document, but there's some artifacts that would probably find themselves in a software design document. This idea is supposed to be a separate software design document, and in fact, there's a separate assignment where we will come up with a design document. We'll have all these comprehensive design artifacts in there, right?
So you have to come up with do you have to come up with all these different diagrams within that document of all the different perspectives?
Yeah, but you remember, I told you this course is quite easy. You know what makes it easy? It's all about tooling, right? I'm just, and these are important questions you're asking. It's important because you want to understand why we're doing this and where we're going, where we're coming from. Thank you for that question. So if you look at draw.io, I suppose you can use that. It's there also, right? Or even Dia, actually, I can show you just now. But if you look at Lucid Chart, right, which I think hopefully most of you are using, what you notice is that there are already templates that are there, right? You don't have to draw these things from scratch. Nobody does this anymore, right? What you need to know is you need to understand the syntax. So when we go through things like use case diagrams, once you understand what the system boundary is all about, what it means, for instance, right? when you look at a UML diagram like what I'm loading, right? Please load, why? What I'm going to load right now. Once you understand what the sticky figures are all about and things like, I don't know how to zoom here. Suppose, I don't know. Once you understand what these sticky figures are all about, right? What this is about, generalization, right? What it means for you to kind of like generalize a user like NRFC customer and customer here. Once you understand these things, all you have to do is identify a tool of choice. I do encourage you to use Lucidchart. There's a reason why. It looks beautiful, right? Tell me it looks beautiful. You can identify a tool of choice. It could be Lucidchart. It could be draw.io. It could be Dia, right? All of these things are there, right? If I go to Dia and I go to, I guess I'm just going to go to UML here. You notice that I have these sticky figures, right? Actor, I can define system boundaries and all these generalizations, right? Where I get to have like another act or something. Here's the thing here, right? So it's going to say student or something, right? Student, and then you can generalize student by, I guess, specific type of ICT 11 student or something, right? So all we have to do is, and the syntax, I assure you, the syntax is quite easy to learn, right? We're not going to look at all the models that are out there, just a few select models, the important ones that will ensure that you're developing the right thing. And in fact, it gets even better, right? For certain artifacts like class diagrams, I don't know if you discussed this when you looked at UML diagrams, right? You can actually use sophisticated tools that automatically generate code for you. So if you're developing using Java programming language and you come up with a class diagram, like I'm just going to showcase find template class diagram, I guess. You come up with where is the class diagram here? And I know I used, I don't know if Enterprise Architect is still around. When I was a student myself, when I was doing my 4th year project, I used, and I'm ashamed to say this, I used a cracked version of Enterprise Architect. Guys, I will share, I should scan, I have my report somewhere. I'll scan it and I'll share it with you. Crisp, clean, right? I'll share it with you so that you see it. You can actually generate code. And this is the essence of software engineering these days, right? You do not develop things from scratch. So you come up with a class diagram similar to what Lightroom is opening right now, right? You feed it with the correct things like the attributes, right? The characteristics and the methods. At this stage, you probably understand the representation that is here, right? You know that this component here is filled with characteristics or attributes, right? When you're creating a class, I don't know if you go to a stage where you're creating classes in Java, right? You're creating a class. The class is going to have variables, right? Attributes. Those attributes, besides attributes, you have methods, right? The setter methods, getter methods for classes, right? These would be like these things that are at the bottom here. Using this, some tools will actually allow you to generate code, skeleton code. So you don't write, nobody writes code from scratch anymore. It's gone now, right? Those days are over. I guess when you're learning, maybe you could do that. But also nobody writes these things. Well, maybe we're going to do that, which is quite sad. Nobody writes these, you handwrite these things. So I'm drawing a class diagram. There are tools. It's inbuilt. I mean, you can just take your pick. I'll go draw.io and you notice that pretty much has the same things, right? I come here, I'll choose which artifact I want to draw, right? I guess I want to draw a class, I don't know if I can, sequence diagram, right? Class diagram, UML, right? You guys go to UML and maybe sticky figures, I can't find them. Oh, anyway.
So the level of, I know like you mentioned, I don't know if you mentioned it, like if this for the client's benefit. Like whose benefit is it for mostly? Is it for the developers or is it mostly for the clients to see how it's going to be structured?
Well, so it's actually, it's contextual. It depends on which particular diagram you come up with. So for things like state machines, for instance, or activity diagrams, those are more for the people that are going to be writing code. You have to think here, right? When you're for the small applications that you're developing, these toy projects we're working on, it's okay for even one person. I do some pet projects that I work on. One person does the elicitation of requirements, the design, the implementation, the testing. But when you are building sophisticated software, you collaborate with other people that might not be co-located with you. There's a separate team that collects the requirements, a separate team that will probably come up with a formal SRS document. There's going to be a separate team that will come up with a design artifact, a separate team that is going to build the software, a separate team that is going to test the software, a separate team that is going to deploy the software. You have so many different moving parts because you have different people, different groups playing different roles, located in different parts of the world. You need to standardize these things. So to answer your question, this is meant for different categories of people, developers, the customers, people that are going to do the validation and testing, people that are going to deploy the software. There's even deployment models, right? If you look at the templates that you have access to here, I guess, I don't know. I guess deployment. I don't know if I can find a deployment model, an example of a deployment model. Where we go, right? So we're not going to look at deployment model, but you kind of have an abstract representation of how you're going to deploy this software. You just don't develop software and say, we're going to install it on some Linux platform. It has to be planned, right? And there's specific design artifacts that you come up with, right? So again, great question, but it's meant for different classes of users. And we mentioned this, maybe we should bring it in the example, something, the test. But we mentioned this, if you remember, in one of our conversations, in lecture series number 6. If we didn't, then I should mention it right now. I will apologize that I didn't. We mentioned that the readers of this, where are you? The readers of this so-called SRS document, there's so many of them, right? I hope I can find that. There's so many of them. I don't know where that is, but I thought we did mention this. We identified different classes of users that get to read this SRS document. It's not just the developers. It's a broad spectrum of you. There we go, right? There we go. When you're coming up with your SRS document, right, you have entities like the customers, right? The people that are going to be interacting with the customers, managers, right? Working for managers representing this company that you're developing software for, irrespective of whether these people are going to be interacting with the software. System engineers, right? And this makes sense. Why? Because if something goes wrong once you deploy the software, IT support has to debug, right? The people that are going to be testing, the testers, software testers, and this friend of mine who was paid quite a huge sum of money for some NGO when we just finished, right? His sole task, his sole purpose in life at that point in time was to test software, right? You would wake up, get dressed, go for work, and all you would do is just test software, right? Develop test cases. It's kind of interesting, I suppose. It's boring for me, but so different user classes, right, would use this thing for different reasons. I hope that answers your question. Thanks for that question, I suppose. Yeah. And then so another perspective besides the structural perspective is the behavioral perspective. You want to model exactly how the software is going to behave, right, when exposed to a certain stimuli. So these would be things like state machines, for instance, right? And to a certain extent, I guess, interaction diagrams, like sequence diagrams. And then it turns out that our focus, there's, in as much as UML happens to be one of the most widely used ways, less and less now, but ways of trying to come up with system models or developing is not the only way, right? There are other ways of doing it. In the wake of so-called agile techniques, people are increasingly or gradually doing away with coming up with these UML diagrams. Why? The reason is simple. Because for the idea behind these design artifacts we're talking about here is you would have decided that you're adopting the so-called waterfall model, right? Or something akin to a waterfall model, where you collect your requirements and then you come up with a comprehensive set of design artifacts. And then after you do that, you start implementing your software.
You guys.
Yes, hi. Yes, we are here. I thought someone said you guys. I don't know what that was all about. Hello? Okay, great, okay. So here's the thing. It turns out that UML modeling happens to be, or it used to be at least, I think it's still the case, one of the most widely used ways of trying to come up with so-called system models, right? So we will look at things like activity diagrams, right? Which will typically showcase or outline the different activities, the processes associated with the software that you're developing, and how data gets to be processed by your system. Use case diagrams, those sticky figures I was talking about with the system boundaries, which will outline the interactions of the system and the environment. Typically, the most useful thing that people tend to, if I can undo this and go back to the sticky figures here, very useful. Just by looking at this, you don't have to read anything else. You know what sort of features your software is supposed to exhibit. Like I think this is an ATM system, right? You know that this ATM system is going to have a withdraw feature, a transfer feature, a deposit feature, a register ATM feature, and a read log feature, right? And you know which sort of different users or entities that are going to be interacting with these different features. And just by looking at this, you can already have an idea as to what sort of capabilities this sort of system is supposed to exhibit. Right? Very powerful, right? Extremely powerful stuff here. So we'll look at use case diagrams, also look at sequence diagrams, I suppose. This is not a comprehensive set of UML diagrams. If you notice, I think deployment diagrams are not here, but these are some of the things we're going to look at to help us develop our SRS document and to help us fully understand how we get to translate the design artifacts into code, right? So we'll look at sequence diagrams, which will show us the interactions that take place between the different actors, right? So this would be end users and external systems, for instance, and the system that you're building. So when I log in, what happens? How does the system respond? If I submit a wrong password, how does the system respond, right? And then we'll also look at class diagrams. Now, it's by tradition, class diagrams we have to look at because if you look at how you're being taught how to program, the focus is usually on an object-oriented programming language. In your case, it was the Java programming language in 2010. Right? So we have to use class diagrams. We are hoping that the vast majority of you are probably going to use the Java programming language to implement these toy systems that you're developing. It doesn't matter though. If you decide to use what you're being introduced to in 2010, aka PHP, PHP is object-oriented. I don't know if it's object-oriented, but you can mimic object-oriented programming in PHP. Did they teach you this? Object-oriented. Have you gotten to the stage where you're discussing PHP and whether or not it's an object-oriented programming language, how you get to create classes in PHP? It's the same concept, really. It's just that the syntax is different, though. Same concept, same classes you're creating in Java, you'll be able to create in PHP. Have you started looking at server-side scripting using PHP?
Not yet.
Okay, I'm sure you will. Anyway, so once you do that, just remember that when we discuss class diagrams, you don't have to restrict yourself to the Java programming language if you think that using an easy-to-use language like PHP, if you perceive PHP to be easy, will be beneficial to your group. Then you can take advantage of the object-oriented features of PHP and be able to come up with different classes associated with the software that you're developing. They're simple classes, really. And then state diagrams, which will typically show how your system gets to react with internal and external events, right? So I'm just gonna, we're just gonna pause here before we start looking at the individual components. We start looking at, I guess, the after tomorrow here. But just a short talk here about so-called graphical models here. Even though most of the modeling is usually graphical in nature, right? If you think about it, in certain instances, it might not be, right? Like for use case diagrams or use case modeling, you tend to have tabular notations, which we, I guess, introduced in the previous lecture series here. But these graphical models are tremendously useful in that they help foster a discussion about the system that you're developing or you're modifying. And you want to have this discussion, especially with your clients. Why? One of the things that is instrumental when it comes to development of software, if you remember the different aspects of software, is the quality attribute. One of the easiest ways of ensuring that you develop high quality software is to make sure that it conforms to the customer needs or requirements. How do you do that? You engage the customer. You consult the customer through and through, right? Irrespective of the model, like the SDL software development model that you've decided to adopt. But also these graphical models are tremendously useful because it's a way of documenting the existing system or the system that you're developing. Once you come up with a comprehensive set of these graphical models, you can actually you can actually go ahead and implement your system using the design artifacts alone. Right? Assuming that comprehensive enough that the requirements that fed into the design are complete and correct, right? Key features of requirements. I'm going to pause here, right, and suggest that we continue this conversation on Thursday. But unless if maybe you would want us to have a query session, a very brief, I guess, walkthrough of what to expect on Friday, on Thursday, we can do that, or we can continue with lecture series number 7. Think about that. Class reps can get back to me about what you want to decide to do. But I just wanted to give you a heads up that I would like to already initiate a makeup session for Saturday for lost time. I will propose time slots either early in the morning or late in the evenings on Saturday or Sunday. I'll leave it up to you to decide. I want us to catch up quickly so that we can get back on track. Unless if there are any questions with the brief overview of system modeling before we transition into the specific categories of the different models that are out there. So context models, interaction models, structural, behavioral models, and then we'll transition model-driven engineering. Any concerns or questions so far? Okay.
Are we going to make all the models in our project?
Yes. All of these here. Well, we'll have aspects of, we'll certainly, all of these categories we're going to model. So we'll have context models. We will have interaction models, structural models. So in here, it's DFD diagrams, right? Data flow diagrams. In here, it will be just use case diagrams. In here, it will be class diagrams. In here, it will be maybe state machines and activity diagrams. Maybe 1 or 2 of each, so that we have a feel of how we get to model this thing. Again, this is probably going to be the easiest, like in terms of practical nature of what we're doing. If you're following through for it, this is important, right? It's easy because all you need is to learn how to use the tools. That is all. Think about this for a second. There are templates that, whether you're using Dia has a whole bunch of stencils, by the way. You can look up stencils for Dia if you're using Dia, right? All you have to do is just learn how to use the tool. Everything else is easy. Oh, guys, you should look up Enterprise Architect. I use this a lot. Enterprise Architect. I don't know if it's still there. Really great tool. I used this many years ago. Between 2006 and 2007, when I was working on my capstone project myself, I used Spark systems. They're still around. I used Enterprise Architect. Beautiful artifacts that were generated. Those days, we didn't have cloud-based applications like Draw.io and Lucid Charts, and we didn't have Dia, certainly. I don't know if Dia was still there. So yes, Master Nkata, we shall draw all of these, at least one from each category. So in here, we shall learn how to draw context diagrams or data flow level 0 data flow diagrams. In here, we shall learn how to come up with use case diagrams. In here, we shall learn how to, and perhaps interaction sequence diagrams in here as well. In here, we shall quickly learn how to come up with class diagrams, which I think you did, because I think someone mentioned that you looked at class diagrams in 2010, thanks to Piera. And then in here, maybe we'll look at state machines or something, I don't know. Okay, I'll see you after tomorrow. I'll send out another reminder to ask if maybe we should have a recap of what to expect on Friday, on Thursday. So a walkthrough, like we used to do in first year, of what to expect on Friday, I guess, on Thursday. Yeah.
I think, Doc, that will help out.
Oh, okay. Thanks, Castor, for the... Okay, I'll see you when you see me, which is Thursday. And I know a lot of people are going to come out of the woodwork here because we have a test. Instead of having 10 and 13 people online, right? There's a test here. Take that seriously. Thank you, and see you when you see me. Bye-bye.
Bye, thank you.